Hi there. My name is Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech, and I want to play a game. I'm going to ask you a question, and I'm going to ask you to leave your answer in a comment below. I'm going to play you a series of synthesized voice signals created by summing a small set of sinusoids. The parameters of that sinusoid will stay constant within a given frame, that's a particular period of time, but can change from frame to frame. The parameters were extracted by performing a spectrogram style analysis on a real speech signal and extracting the most salient components. Now, there is some trickiness in putting the signal back together because you want to avoid glitches from one frame to the next. We won't worry about the details of that here. In this example, we're using 10 millisecond frames. So what I'm going to do is I'm going to play an example with 2 sinusoids, one with 4 sinusoids, and then one with 9 sinusoids, and then play for you the original signal. Please leave a comment noting which number of sinusoids was the first version of the signal that you heard that you were able to understand what was being said. I'll play each example twice. Here's 2 sinusoids.
Cats and dogs each hate the other. Cats and dogs each hate the other.
Now here's 4 sinusoids.
Cats and dogs each hate the other. Cats and dogs each hate the other.
Here's 9 sinusoids.
Cats and dogs each hate the other. Cats and dogs each hate the other.
And here's the original signal.
Cats and dogs each hate the other. Cats and dogs each hate the other.
Now that you've heard the original, listen to the version with 2 sinusoids again.
Cats and dogs each hate the other. Cats and dogs each hate the other.
It will probably now seem to you obvious what it says, even if it didn't the first time you heard it, because your brain is primed to hear those particular words. So here's a zoomed-in section of the spectrogram of the synthesized 4 sinusoid signal. This is a small section of this larger spectrogram, with a square indicating what this particular section was corresponding to. And the thing I've always found interesting about voice spectrograms is they kind of look like fingerprints. Here's the version with 9 sinusoids, and here's the version with 2 sinusoids. Notice that if you just look at the time domain version of the signal at this scale, you can sort of see that there's different words, but there's not really a whole lot more detail than that. And the original signal and the 2-sign version of the signal don't qualitatively look much different. Here's a zoomed in section of the 2 sinusoid signal, and you can sort of see, yeah, it looks like 2 sinusoids.